Okay, so try the Explore here, and I'll pause it and then just draw on diagonals. A diagonal is something that goes from one corner to the other across the middle, so that's a diagonal. So go ahead and do number 1, and then we'll chat. Okay, so if you're trying to estimate the lengths of these, just know that it's always going to be the longest side. So if this is, say, 3, and this is 1, 2, 3, 4, 5, if you estimate and you try to, like, measure off where the 5 is, then, you know, you might think, oh, that's 16-ish, maybe 15, or maybe 5.9. But if you take this 5 on a piece of paper, mark it off, and swirl it over there, that diagonal is going to be the longest side. And that's actually going to be true on all of these. So the diagonal is always the longest side. And what we call that is we use a letter C for that. But that is always your hypotenuse. Right? So the longest side. The other two sides of the triangle that are not the longest side, and actually these are in right triangles, these guys are called your legs. So there's a leg, there's a leg. And there we usually call them A or B, but it doesn't matter which one's which. So, for example, this side could be A, and this could be B, or vice versa. I could call this side A, and this side B. So, the kind of the short and the medium, or the two other lengths, are legs, and they're A and B, and then your hypotenuse is C. All right, let's scroll down and look at the bottom. And so we're going to talk about Pythagorean Theorem, which is the bottom here. So read this page, look at example 1 in the book, and I'll pick up on page 266. Okay, I had to edit a little bit there. So, so Pythagorean Theorem is a squared plus b squared equals c squared. And remember, I said that a and b are your legs squared. And then C is always your hypotenuse squared. And I think what some people don't realize is this is a formula all about area, and it's the area of squares. We use it to find side lengths, but it's really not a formula about that. So for example, if I have, say, a 3 by 3 square, and I have a 4 by 4 square, and I do this diagonal, okay, and this diagonal is actually going to be a 5 by 5 square. This is kind of a famous one, though, so that's why I know this. This usually isn't that easy. So say this is 3 centimeters, 4 centimeters, and 5. So this formula is saying the leg of one of the sides, and it's the area of that leg. So that's why we take 3 squared, because it's a square and it has an area of 9. And then we take the other leg, which again, they're not, if you have a right triangle, they're the two legs that are not the hypotenuse, all right? So the two sides that are not the hypotenuse. So 4 squared is the area of that medium one. So I have the area of the small square, which is 9. I have the area of the medium square is 16. And then your longest side is your hypotenuse, and 5 squared is 25. And so that's saying that 5 times 5 is 25, but also that these areas really should add up to 25, which they do. So this is about the area of the small, the area of the medium should add up to equal the area of the big. The thing is, we use this a lot of times to find side lengths, all right? And so then we need to unsquare it or square it, okay? So hopefully you read through those examples earlier. So try 2a and b, and again, using this formula, just knowing you're going to have a variable, and to undo squaring, you're going to end up having to square root. So try 2a and b, and again, if you need to reread some of the examples, go back and do that, and then we'll pick up here. Okay, so let's look at this. Find the length of the hypotenuse of a right triangle if the legs are each 10 feet. So this leg is 10 feet, this leg is 10 feet. And again, Pythagorean theorem is special. It only works on right triangles, so you need to have a 90-degree angle in here. All right, so it's important that it says the word right triangle. All right, so Pythagorean theorem is a squared plus b squared equals c squared. Always look kind of for the hypotenuse first, because that one matters. The other two are interchangeable. But notice I don't know c, that's a hypotenuse. It's the longest side. It's across from my right angle. So sometimes it can be rotated. So the right angle could be up here, and then this could be my 10 and my 10. But again, the longest side is always opposite your biggest angle. So this is still C, even if it's rotated. So I don't know my C. But again, 10 squared is the area. So if this is like 10 by 10, it's its area. So 10 squared is 100, 10 times 10. And then the area of this guy, these are the same. So this would be 10 by 10. So 10 squared is 100. So again, that formula is giving you the area of those squares. So if I add them up, I get 200. And that should be the area of the square that's over here. So it should be bigger, and it should have the area of this plus this. So again, how do you solve equations? You know more than you think you do. There's no adding, no subtracting, there's no multiplying, no dividing, so then we undo exponents. So how do you undo square root? Well, you square root. So I'm going to square root. So C is, and then the exact answer would be the square root of 200 if you want to be exact. And it would be, what unit are we in here? Is it feet? But if I want an approximation, I'm going to hit the square root of that, and that would be about 14.1 feet. So you're going to need that square root key on your calculator, which makes sense, because if you take 14 times 14.1 times 14.1 and get the area of that, it should be as close to 200, although there might be some rounding. So that's how we use Pythagorean theorem to find a missing side. We use area, but then we undo the area to get a side length. Okay, let's look at B. Find the side length of the right triangle if the legs are the same length and the hypotenuse. Okay, so I kind of drew on top of my picture over here, so I'll erase some of the stuff. All right, so in this case, it's kind of sounds similar, but here we have a right triangle, but this time they're saying what? The hypotenuse is 10 feet. So think of Pythagorean theorem. I'm kind of like, okay, well, I have some issues here. But then it says the legs are the same length. So that means if this is, say, A, so is this. They're both the same. So I don't need two variables. I don't need A and B. But I do know that A squared plus another, in this case, instead of B squared, because they're the same, equals C squared. All right, so the area of this guy plus the area of this guy, if I could draw big squares there. Right? So A squared plus A squared, which would give me 2A squared. And remember, when you're collecting like terms, you're just adding. So the power does not change. I'm not multiplying and creating a new object. I'm just adding. Okay, now this one I actually know the answer. 10 times 10, or 10 squared, is 100. So if I take 10 times 10, I get an area of 100. And again, you know more than you think you do. You actually know how to solve this equation, even though maybe you're like, I've never seen this before in my life. But you know that when you solve equations, you're doing order of op backwards. And so if you think of order of op, parentheses, exponents, multiply and divide, add and subtract, and you're going this way. But when you're solving equations, you're doing the reverse. So let's think about what's happening here. I am, in real life, if I knew what A is, I'd square it first. So I would square first. And then I would, multiply by 2 after I got that answer. All right, so that would be going forwards. Okay, I do my exponent, and then I multiply. But I'm going backwards, so I have to do the reverse. So to get rid of multiplying by 2, I would divide by 2. So A squared equals 50. And to get rid of squaring, I would square root. So I'm going to square root both sides. And if you square root a square, you just get back to A. These kind of cancel each other out. And so A equals, now, the square root of 50 is an exact answer. If I want an approximation, I'm going to use my square root key on my calculator, and I get about 7.07 feet. Now, technically when you square root, you actually get 2 answers, but because these are like real life problems and it's a distance, we only say the positive one because the negative one doesn't really make sense. But you do have to be a little careful because remember how the degree or the exponent tells you how many answers you have. So for example, if I give you x squared equals 25 and you square root on your calculator, technically there are 2 answers, a positive and a negative 5. Now your calculator is only going to give you the positive 5. But 5 times 5 is 25. But also notice a negative 5 times a negative 5 equals 25. But with Pythagorean theorem, you're dealing with distances and area and things like that. So a distance can't be negative. So that's why you only get 1 answer. But notice normally when you have an exponent of 2, you should expect 2 answers. It's just that the negative doesn't make sense in this case. All right, go ahead and let's try just a couple problems here. So pause. I'm going to give you a couple problems to do in the margin, and then we're going to move on. Okay, so say we have a right triangle, and maybe we have, this is 8 feet and 10 feet, and we're trying to figure out that side. Okay, and we have a right triangle, so anytime you see a right triangle, you think, oh, I could do Pythagorean theorem. So a squared plus b squared equals c squared. Which again means the area of kind of the small and medium should add up to the area of the large. All right. So I always like to start with C first, and C is always across from your right angle. It's always the longest side. So 10 times 10 is 100. And then the other two sides are your legs. They don't matter. So 8 times 8 is 64, and then I'm just going to have a squared. But you could have 64 plus b squared. Doesn't really matter. All right, so again, if some of you are like, I don't know how to solve this equation, the answer is you really do. If you knew what a is, you would square first, and after you got what a squared is, you'd add 64 to get the answer of 100. But we are going backwards. So the reverse of adding 64 is subtracting 64. So we're going to get rid of that 64. And these guys cancel, so we get a squared equals 36. And then to undo squaring, we're going to do the reverse, which is square rooting. Now, again, remember what I said. When you have a perfect square, you get two answers, because 6 times 6 is 36, and a negative 6 times a negative 6 is 36. But because we are dealing with distances on shapes, it doesn't make sense to have a distance of a negative 6. So we're going to get 6 feet. And so this side would have to be 6 feet. All right. Pause it a second. I'm going to draw another one, and then I'm going to have you try that, and we'll see how you go. Notice that why did we subtract here? Because we knew the hypotenuse, and we knew one of the legs, so we had to bring it over to figure out the other guy. All right, let me give you the other type here. Okay, so I want you to try to figure out what the missing side is on this one. And again, you have a right triangle, so you know you're doing Pythagorean theorem. So try this, see what you get. All right, so I see a right triangle, and I'm trying to figure out the missing side, so I know it's going to be Pythagorean theorem. All right, and so I always look for C first. So C is the longest side, and it's always across from my right angle, because your biggest angle will give you your biggest side. So this is C, and so I don't know what C is, so I'm just going to call it C and C squared. Now, the other two sides I actually know. So the area that's going to come off over this guy, a big square, 6 by 6 would give me an area of 36. And a big square over here would be 8 by 8, which is 64. So this time I can actually add these. Like they're together, a number plus a number just makes more numbers, so I get 100. So really the only thing I have to undo is squaring. There's no adding to undo, there's no subtracting, because the variable is already on its own side. And the numbers are on their own side. So at this point, I really just have to square root both sides to undo squaring. Now again, remember, if there's an exponent of 2, you might have two answers, like 10 or negative 10. But the thing is we're dealing with distances, and you can't have negative distances. So the square root of 100 is 10, and that would be 10 feet. So again, the 100 would represent the area. If I had this guy. Okay. But again, I don't want the area. I want how long the side is. So when you square root, you get the side length. All right. Let's see. I think we're going to start the top of page 267. So if you want to read that, and then I'll get you going on that page. Okay. So Pythagorean triple is kind of a special thing. And it's when the numbers work for Pythagorean theorem. So like you shove it into a squared plus b squared equals c squared, or sub it in, and it works. Like it actually works. So like 3, 4, 5, I started class with, that's kind of a famous one. 3 squared and 4 squared, longest side would have to be c. But notice 9 plus 16 actually does equal 25. So that is what we call Pythagorean triple, because it works in Pythagorean theorem, and they're whole numbers. There's no decimals. A lot of times you square root stuff, you get decimals, 13.8245, things like that. All right, so what I want you to do is go ahead and fill these out. They're giving you A and B, and they want you to find the hypotenuse C. So go ahead and fill out this chart using Pythagorean theorem, and there's not going to be any decimals here, so you should be getting some nice numbers. So fill it in real quick. Okay, so if you look at your numbers, you could do Pythagorean theorem over and over and over again. This guy right here. But what else could you do? So we'll look at the next video for that.